a lot of stuff went wrong. A lot of stuff went wrong. I'm Josh Whitman, CEO of Whitman Technological. A lot of stuff went really wrong during the printing, and I had several failed attempts and ultimately several printer failures. We addressed all of those and even had some really cool opportunities to improve things as we were dealing with the things that were failing. So you got to take the good with the bad. You got to look at every setback as an opportunity to do something new and make it better than it was before. So before we can start printing, we need some objects to print. And in order to make those objects, we got to do a little design work. So let's hop into FreeCAD and let's build up our gears and our brackets. Let's put all our components together and check the alignment. And then we'll have our objects ready to roll out. So I wanted to make a better looking time lapse for you guys, so you're not watching these videos that are just blurry and terrible, but you're actually seeing the object take shape during the printing. So to make that happen, I mounted the camera directly onto the print bed. The print bed is sliding back and forth constantly during printing, so it's moving the object around a lot. But now that the camera is in the same frame of reference as the object, as the print bed moves back and forth, the position of the object in the camera frame stays constant, so you get a much better view of what's happening. However, when I mounted that camera on the side of the print bed, it bumped into the printer frame during printing, and you can see exactly where suddenly the printer frame and the camera intersected as it shifted the entire print bed over, and this object is just offset. And so that was one hilarious disaster. Then, after I fixed that mistake, I was printing and it just kind of ran out in the middle. It didn't run out of filament, it just stopped extruding. And the reason is that the extruder gears there's a large gear and a small gear, and the motor's hooked up to the small gear. And because the small gear has significantly fewer teeth, each of those teeth gets several times the wear and tear of the larger gear. So here's my small gear from the extruder motor, and it's worn out. If you compare the thickness of those gears with one that's freshly printed and barely used, you can see this is quite a bit narrower up on the teeth here. And the teeth lost their bite and they couldn't spin the larger gear anymore. So fortunately, I always print an extra one. The first time one of these wore out, I realized it was kind of a consumable and I needed to have extras on hand for when it did fail. I was able to pop this in place and print a couple replacement gears. Before we go any further though, let's hear a word from our sponsor, My Own Software. This video is made possible by Moneylender Professional. A labor of love since 2004, Moneylender Professional can seamlessly calculate interest and track payments for virtually every type of loan, lease, or contract. Perfect for single users or teams, 3 loans or 1,000. Generate professional, customizable statements and letters, fully auditable, completely configurable. If you have loans, track them with Moneylender Professional. Then I had some major problems with bed adhesion and ABS curling. ABS is a tricky material to print with. One of the big drawbacks is that it will curl quite a bit, and as this one curled up in this back corner here, the hot end caught the corner and knocked it off the print bed completely. At that point it just scribbled plastic all over it. After all that scribbling, the nozzle on the printer was clogged, so I had to remove the hot end and clear out all the plastic that was clogged in there. The easiest way to clean out the hot end is to just cook all the plastic out. And that's kind of fun, and it's really, really quick. And you're ready to reinstall in just a matter of a few minutes. So at this point, I was getting kind of tired of all the failure. So let's do something that I know I can get right. It's really hard to mess this up. Let's make a banana bread. inside the hot end, there's a nylon tube that goes from the extruder down to the hot end. Now, when I reinstalled it, I don't think the nylon tube was seated all the way properly inside the hot end, because then when I tried to print, that connector cracked and there was a lot of internal pressure from molten plastic that was seeping out the sides of that nylon tube, and it actually cracked the connector and then leaked out all over the hot end. And of course that print failed, and I had to take the hot end back out and cut away this big chunk of plastic that had formed. And as I was cutting that away and removing the hot end, that connector was already cracked, but then it broke all the way and became completely unusable. So I ordered one. It cost, about $30 or something. I cut myself a new stretch of nylon and made sure that it was seated extremely well and pressed very tightly into both the hot end and the tightening hex nut at the top, and then reassembled everything, and it was back to printing just fine. And in the downtime, while I was waiting for the delivery of this part, I couldn't do any printing, and I thought it was a great opportunity to kind of rearrange the electronics and the wiring on the 3D printer. Now, I got a couple of Raspberry Pis that I don't have too much use for, and I put OctoPrint on there, which I had never heard of until now, and how awesome that was. It drastically improved the quality of the time lapses. So we got to take the good with the bad, take the opportunity, take that space to look at what's happening and try to build something a little bit better. And I think we really succeeded with that part of it. Eventually, I got 2 brackets printed out, and they came out pretty nicely. And I filed off kind of the rough parts on the insides of the circles, and they fit together. And I put the axle and the idle gear and the motor on here and kind of put it all together. And when I set the sizes on the little notches inside here where the bearings are going to fit, I set them to exactly the diameter of the bearings. I saw a really cool comment on a YouTube video where they talked about the sizing of objects that for how the objects are going to fit together. And they said that if you use the same inner diameter for the piece as the outer diameter of what fits into it, that's called a size-on-size press fit. If you're going to make a hole, you want it to be about 0.2 of a millimeter larger than the bolt that's going to fit through it. And so I took that information to heart, and I redesigned it again so that the inner notches are, they have an extra 0.2 of a millimeter. The radius is 0.1 of a millimeter larger than the bearing that's going to fit into it. So it's still going to be very, very tight. Also, I saw in a video that, I don't know if you can tell here, but it's got these crumbles and it's kind of messy. Well, it's even worse on these larger circles, where when it goes to print and it gets to the top, it's kind of just extruding plastic into the open air. There's nothing underneath it to print against. And that can be really messy, and I found that really affected the integrity of the inner diameters. When I did that redesign to make the diameters larger, is I put a little teardrop shape at the top. And that teardrop shape allows like a smooth kind of roof line that the printer can print at that angle very well. So it ended up printing out very cleanly through those parts that kind of go over the open air. And I didn't have to do any filing at all on this when it was done. Also, I made it a little bigger so I could fit a socket in there to attach these together. And ultimately, I ended up with something that technically, functionally exists. I don't want to say it works because it doesn't, but it's very close. So now that we've made it all the way here, let's see how it works. And remember, the herringbone gears are extremely quiet, which is great. So far, so good. Oh yeah. I mean, you wouldn't even notice this coming into the room with you. This is just They'd be like, whoa, where'd you come from? The robot's sneaking up on you. It's totally stealthy. It's beautiful. That's a thing of beauty right there. Okay, so that's hilarious. It's extremely loud, but that's because I only gave myself 1/4 of a millimeter of extra space between the axle and the idle gear, and then 1/4 millimeter between the idle gear and the motor, and that's just too much pressure. If I pull these apart a little bit and we try it again, you can see it's a lot quieter. It's only because it's pressed together really tightly. So I actually have to redesign these brackets again and make them just a little bit farther apart so that the gears aren't being smashed into each other, and the fact that they're 3D printed so they're not dimensionally perfect, that wiggle room will account for that. But once we do that, we'll have an actual usable foot, and then I'll need to design for the back here. Then for the back here, I need to design a bracket that's going to come down and also mount to these holes, so that where we connect to the rest of the robot, the axle is supported from both sides. So a little bit more redesign on this, and an additional bracket here, and I feel like we'll have a fairly functional robot foot. Now I do have the range sensors, the sonic range sensors, and you'll notice I have a couple of holes here and a couple of holes down here, and what I would like to do is eventually put a shroud over all of this so the gears aren't exposed, and then same thing, have a shroud over this side as well, so it's completely encapsulated, and at that point I could mount the sonic sensors into the sides to be able to see forwards and backwards and measure distances. What an exciting adventure. So many setbacks and disasters and hilarious mishaps. And in the end, we got through them all, and our whole system is for the better because of it. So, you know, a failure is only a failure if you give up. If something doesn't work, try again and learn from that mistake and make it better. And today my 3D printer is in better shape than it ever has been. It's about 6 years old, and I'm really impressed with how long it's been running. And I don't anticipate it failing thoroughly again for at least another couple of weeks. So that's really great. Also, the quality of the time lapses is significantly better. I'm Josh Whitman with Whitman Technological. I love science, and I hope you do too. Whisper quiet. Look, it's so quiet. Oh, it's just, you can't. Oh, it's so quiet. There it go. Oh, yeah. I don't even know it's running. It's so quiet. I can't even tell. It's just.